Question 2, our random variable is the weight of a pear. And we know that the weight of pears in an orchard, this random variable is normally distributed with mean 0.32 and standard deviation 0.01. So if a single pear is selected at random, what is the probability that its weight will be between 0.28 and 0.34? So we have a single pear, so we know we're dealing with the population distribution, which we're given is normal with mean 0.32 and standard deviation 0.01. So to find the probability that the weight of a single pear, that x is between 0.28 and 0.34, I'll translate that into a probability statement, which looks like this. Since we have a normal random variable, a normal population distribution, we can just convert this to a standard normal. Remember our conversion formula? Subtract the mean, divide by the standard deviation. So we know that 0.28 will be converted to 0.28 minus the mean divided by the standard deviation. And 0.34 gets the same treatment. So let's plug each of these into our calculator. 0.28 minus 0.32 over 0.01. You should get -4. 0.34 minus 0.32 over 0.01 should get 2. We want to find the area between two z-scores. As a reminder, how do we do that? Let me draw my picture. Say -4 is here, and 2 is here. So I want the shaded area in the middle. Well, the shaded area is equal to the area to the left of 2 minus the area that I don't want, which is the area to the left of -4. I can look up these values on my table. The area to the left of 2, according to my normal table, is 0.9772. And the area to the left of -4, -4 is a very negative, very small z-score. So I can approximate the area to the left, since it's not on my table. I can approximate the area to the left with 0. So the probability that a single pear will have a weight between 0.28 and 0.34 pounds is 0.9772, or about 98%. Okay. Part B, we want to figure out the probability that the average weight in a sample of 4 pears will be between 0.28 and 0.34. So in other words, we want to find the probability that the sample mean, the average in the sample mean, is between 0.28 and 0.34. Well, what's the distribution of the sample mean? To use the central limit theorem, I'll abbreviate with CLT. We need to satisfy 2 conditions. So let's check if those conditions hold. First condition is that we have a large sample. Well, is our sample here large? Well, here our sample size is only 4. So n is just 4, which is actually small. So we don't satisfy this first condition. So we can't use the central limit theorem. But it turns out that's not really a problem for us, because remember that we were given that the population distribution is actually normal. We were given that the weight of pears in the orchard is normally distributed. And if our population is normally distributed, so that means that any random sample from this population will be normal. So as a recap, if our population is normal, then a random sample from it will also be normal. If the population is not normal, then we need to use the central limit theorem. To find the distribution of the sample mean. I'll leave that up there. Okay, so since our population is normal, we know that the sample mean must be normally distributed with mean 0.32 and standard deviation 0.01 divided by the square root of our sample size. Our sample size was 4, so the square root of 4 is 2. Remember, take note here that even if we don't use the central limit theorem, if we use the fact that the population distribution is normal, we still have to scale the standard deviation. In other words, we still have to divide by the square root of the sample size. Okay, so now we wanted to find the probability that the sample mean was between 0.28 and 0.34. So now we can convert to standard normal. So we take 0.28, subtract the mean, and divide by our standard deviation, which is 0.01 divided by 2. And we do the same for 0.34. So we take 0.34 minus 0.32, divide by 0.01 divided by 2. If you plug these z-scores into your calculator, you should get negative 8 on the left-hand side and positive 4 on the right-hand side. This is equal to the area to the left of 4 minus the area to the left of negative 8. 4 is a really big z-score, so we can approximate the area to the left with 1. Negative 8 is a really small z-score, so we can approximate the area to the left with 0. So in other words, there's a 100% chance that the sample mean will be between 0.28 and 0.34 pounds.